Hey guys, welcome back to my channel. Hope you are doing extremely well. This is your very own mascot at the site, and today we are continuing a GFG POTD series. As you can see, we have already completed 32 of our days, and it's our 33rd day. Okay, let's see what we have done. So today's question is unique permutations. Okay, unique permutations, as the name suggests, you will be given an array, and you have done redone its unique. I am stressing on unique. So unique permutations. Okay. As the question says, the heading says there are two main steps, that is generating all the permutations and return all the uniques from the above collection. We can deal it in the ways of two subproblems. Okay. Let us look at the second subproblem first. You answer me, if we have a collection which might contain duplicates, how can we return uniques? One possible way of saying is that if the collection is in set data structure, then it is already existing as unique. You just have to convert it into vector of value and return the vector as vector is asked in the question. Okay, so second step is this much only. Second step says in the first step in the first step store the uh, permutations in set. Okay, after that convert set into vector. Why vector? Because the required format of answer is vector. Okay, this is all about the second step. So unique is not a problem now. We have to deal with generating all permutations. So if you already know generating all permutations, no need to watch it again. Okay, if you are clear with them. Okay, otherwise I'm explaining you how to generate all the permutations. Okay, so our problem now becomes generating all permutations. Generating all permutations. So there is actually not a brute force approach for it. So I will be telling you the simple approach only. It is an intuition wise. Okay, telling you the first easy approach. It is also optimized. Okay, this is also an optimized approach. What is it? It says use STL. For those of you who do not know about this STL, there exists a function known as next permutation in the C++ library. And as I think most of you know what is next permutation. Next permutation is, suppose you are at 1 2 3, so next permutation of this would be 1 3 2. After this it will come like what do we say, yeah, 2 1 3, then 2 3 1, then 3 1 2, then 3 2 1. After this next permutation should have been this, but the function returns false. The function returns false, so when it returns false we will stop the value. Okay, also I forgot to mention, the question says you have to return the answer in sorted order. So it is damn simple to store the answer in sorted order. First store, suppose the array given to you was 2 1 3, so make it sorted. It will sort it. When sorted it becomes like 1 2 3, and then store the answers in set and then convert the set into vector. Okay, now what will be the pseudocode for this? The pseudocode will be that sort the array. Okay, create a set. Okay, name as s, or set, remain it as set because it's a pseudocode. Okay, now we have sorted it, so we are existing in 1 2 3. So what do we need to do? First need to push the 1 2 3 into the set and then move 1 2 3 to 1 3 2. So what we are doing, we are actually using a do while loop. Okay, so do set dot insert arr, and after that this finishes, and then while next permutation of arr to begin. This is actually the STL format you have to answer: arr to begin, comma arr dot end. Okay, this is a whole pseudocode. After that you will have to convert it into vector and so on and so forth. So I guess this is actually understood by you. I not do not need to dry run it. Okay. This is actually easy, but this is not an interview approach because it is using STL, and the interviewer thinks that you need to answer it based on your own algo. So own algo would work like own algo can also be using next permutation. You can implement next permutation by yourself and then present the answer. But instead of that, what I'm doing is second is uh, slightly tough, but still optimize approach. So the approach says, suppose you have been provided with an array named as 2, 1, 3, 3. Okay. So my first step should be to sort, to store the, in what could we say, to store the permutations. For that, what I will do is, I will make a recursion structure. I will use backtracking. How? I'm currently standing on this index. Let me remove this. Yeah. I'm currently standing on this index. Okay. Now, the possible ways to generate a sequence is this 2 can remain here, or go here, or go here, or go here. Correct? There are 4 positions for this 2. So what I'm doing is I'm swapping. I'm using the swapping function. Okay. Now, don't care about double threes because what I'm saying is if you care about all threes, you will not be able to find our uniques. Okay. So unique will be handled by the set, and we have to just handle the what do we say? We just have to handle the permutations. So swapping with all of them. First, it will swap with this only, so it will remain same 2 1 3 3. After that, it will swap with 1, so it will be 2 1 2 3 3. After that, it will swap with 3, so it will be 1, so 3 1 2 3, and then lastly that will be 3 1 3 2. Okay. Now we have used all the conditions for second one. Move the pointer to the next one. Okay, so we are here. Now this will give us four more, three more, because now the possible positions for this is this, this, and this, because we have used the first one here only in this thing. Okay, first one is done, so we will move from the index till n minus one. So it will be 2 1 3 3 with itself. With next it will be 2 3 1 3, and then with the last one it will be 2 1 2 3 3 1. Okay, similarly for this one the pointer is actually here, so it will be giving 1 2 3 3. After that, what do we say? Yeah, 1 3 2 3, then 1 3 3 2. Okay, these are the three one. And then with this one 3 1 2 3, so it will give us 3 1 2 3. After that 3 2 1 3. After that 3 3 2 1. Okay, now for these this one pointer is actually here, so it will be 3 1 3 2, the same one, then 3 3 1 2, then with the last element 3 2 3 1. Okay, now the pointer for all these moves at the second index, you have to generate all this in swapping for all this index, so it will be actually 2 1 3 3 and 2 1 3 3 only. You will say that the permutations are same, but I will say no matter, because the set is handling the uniques. Okay, after this 2 3 1 3 and 2 3 3 1. Okay, after this 2 3 3 1 and 2 3 1 3. Okay, these all will give, first one will be giving 1 2 3 3 1 2 3 3. Second one will be giving 1 3 2 3 1 3 3 2, right? After that 1 3 3 2 will be giving 1 3 3 2 and 1 3 2 3. Okay, time for this one, it will give me 3 1 2 3 and 3 1 3 2. After that 3 2 1 3 and 3 2 3 1. After that this will be giving 3 3 2 1 and 3 3 1 2. Okay, now for this This will be giving 3 1 3 2, swapping with itself with the next element 3 1 2 3. Again 3 3 1 2, so 1 2, swapping with itself 3 3 1 2, swapping with the next one 3 3 2 1. Okay, swapping with itself 3 2 3 1, swapping with the next one 3 2 1 3. Yeah. Now the pointer moves at last one. As you can see, the last one has only one option to swap with itself, so the operation remains same. Okay, so I'm not changing that. And you can see these are the all permutations you can achieve. These are not unique, but these are all the permutations you can achieve. These ones, which I'm underlining. You had four numbers, so 4 factorial is 4 into 3 into 2, that is equals to 24. You can count 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24. So you can see 24 permutations are with us, and we have got a correct answer. So we generated all the permutations, store them in a set instead of a vector, and then use the second step to store the uniques. So how will a pseudocode work? Pseudocode will be using our backtracking. So what we are doing is, suppose I implement a function solve. I take my initial ARR, my current index from which I have to start in the swapping. Suppose this is int, and a set where I have to insert. Also use n to mark the where did you have to go at the final. Okay, n is the size of the array. Okay. Now if my index is actually greater than equals to n, in that case return, like, do not add something to the set. Okay, else for int I, going from int up till n minus 1 I plus plus, what we are doing, we are first swapping the elements, swapped. Okay, after that make a recursion call for int plus 1 now, because as you can see, as you are able to see, after doing the part for this we are moving from here. Okay, after doing the part for this we are moving on the next pointer, so int plus 1 it will be. Okay, int plus 1, and remains same, and set remains same. Okay, also after, before or after, you can do anytime as dot insert my ARR. Okay, and then what do we say? Yeah, for the future calls swap it again so that the condition remains same. Swap ARRI with ARR, so as to return back to the same array we got in our hands. Okay, and then return. Second step will be for auto it in s. Suppose my vector is answer dot pushback it, and then after this return answer. This is my second step, this is my first step. I hope you are clear with both. Okay, let's analyze the time complexity for it. So time complexity of it is n factorial into log n. Why? N factorial because we are generating n factorial permutations. Clear? Log n because we are using set. So inserting time is becoming log of n, log of n factorial. Sorry, it will be here. Log of n factorial, right? So I hope you understand this one. And then this is just a minimal part, so it will be using less time than this. So I'm not counting this in the time complexity. Okay, what is space complexity now? Space complexity will be O of n into n factorial. Why? Because we are using set, so store n factorial permutation, and each n factorial permutation is of size n. So n into n factorial. There comes the time complexity and space complexity. Without wasting any time, let me code down the answer for both the approaches we discussed. First one was next permutation, and second one was the swapping one. So first one is using next permutation. What we are doing is first sort the given array, sorted, initialize a set of vector, or you do not have to use a set here. Why? Because next permutation will give the automatically next one, so they will not duplicates. Are you able to understand that? Suppose we are right now with 1 3 5 5. Okay, Next permutation will not give 1355 as an answer. So it will not give the duplicate answers. Not. It will just return 1, 3, sorry, 1, 5, 3, 5. This is the next permutation for this. So your duplicates are not returned in the next permutation. So we will get our unique values automatically. So what we are doing is we are not using a set. We are actually using a vector only to store the answer and reduce the computation time. Vector of int ans. Now do we use a do while loop as you remember. Ans dot push back the current array, and after that, what is the condition? While next permutation of arr dot begin, arr dot end, and then return your answer. Hope it works. Hmm. Running fine for compile and run. Let's try it for submit also. Done. Okay. But stay with me. I will code down the second approach also for you. Second approach, most of the thing will remain same. Name it as S only. Do not need to sort it before. Then initialize a set for storing vector of int. Name it as S. Okay. Now call a solve function taking arr, then in. Then the current index is 0 because we have to start the swapping from the 0th index. Then our set. Okay. Then initial we just have to implement solve. So void solve. First argument is our array, vector int and arr. Size of the array in 10, current index int and set of vector of and s. Passed all of them by reference. Now if my index is actually greater than n, in that case return, simply return. Else what you have to do, for int I equals to 0, I less than arr, I less than n, and I equals to 0, not I equals to in, I less than n, I plus plus. First operation was to swap the current index with the ith element. After that, push it into the set. So s dot insert arr. After that, solve for the next index. Solve arr for n plus 1 and then s. After that, swap it again for future references. We have to swap it because we have to get the initial position back again. So arri with arr end. Okay, and then it okay. Now below we have to just, after implementing the solve function, our set contains the required value. Just take it in from the set into the answer array. Go to it and answer dot push back it. Okay, and after that sort the answer because you have to return the sorted answer. So sort answer dot begin with answer dot end. Okay, let's try to compile on it. Hope I'm not committing any typing mistake. So running fine for compile and run. Let's try it for submit also. So running fine. Hope you like the video, and please, it means a lot to me if you subscribe. Thank you. Have a nice day.